Welcome back. In the previous section, we analyzed the block sorting job and found that it could be broken up into 3 basic steps. Firstly, information gathering. Secondly, decision making. And thirdly, action steps. In fact, any automatic control system must carry out these 3 basic procedures. So, let's begin with step 1 of our automation process, which is to motorize the conveyor. Instead of the operator having to manually operate the conveyor, we will motorize the belt and control the motor from the logic section. The next step is to replace the mechanical height gauge with a limit switch placed exactly 85 millimeters above the belt. We'll connect the limit switch to the logic section of our machine and use the state of the limit switch to send an input signal to the logic. Now, this limit switch is a basic 2-state sensor which can either be closed or open, and it can switch the voltage in a circuit on or off, sending an electrical yes/no message to the logic section of the control system. Therefore, when a long block activates the switch, an electrical circuit is completed and current flows to this control relay. Now, what is a relay and how does it work? Well, a relay is also a type of switch, but an electrically operated one. When a control voltage is applied to its coil, one or more sets of contacts change state, opening or closing the electrical circuit to which they are connected. Like the contacts on our limit switch, relay contacts are either normally open or normally closed. And when we talk about contacts being normally open or normally closed, we are describing their inactive state. In other words, how they respond when nothing is done to them. But when the relay coil is energized, the contacts change over to their active state. Normally open contacts close and pass power, and normally closed contacts open, interrupting the power flow. In this way, a relay can communicate its own on-off signals, because every time the relay is energized, each set of contacts change state, making or breaking the power flow to another device. This relay has 2 sets of contacts, which means that it is able to relay or control the flow of power in 2 independent electrical circuits. Now that we know how a relay works, we're going to use 1 set of its contacts to operate an ejector circuit. And when the relay contacts close, it will be just like the operator saying, "Yes, this is a long block." The electrical circuit is completed. Power flows to the solenoid valve, and the ejector pushes the block off the conveyor. Since this signal from the relay turns the solenoid valve or working device on or off, we call it an output signal. Now, this is how we can describe the power flow on a diagram. Contacts are always shown in their inactive state, so we will draw the contacts in our circuit like this. When a long block is detected, the contacts of the upper limit switch close, and a voltage signal appears at the relay coil. The coil is energized, which makes its normally open contacts close, and power flows to the solenoid valve. So far, so good. After the break, we'll return to add a further stage of automation to our sorting machine.